This is a quick overview of how the periodic table is organized. The first person to develop a type of periodic table was named Mendeleev. That was before 1900. But he took the several elements that had been discovered at that time and arranged them by their mass, the element mass. And he found when he did so, he saw a periodic behavior. He saw elements that had similar properties occur on a periodic basis. And so he started arranging them into rows and columns so that the elements that had similar properties were in the same column. He called this repeating pattern of the elements the periodic law. And here is the definition for it. Mendeleev's periodic table had a lot of gaps because there were quite a few elements that had not been discovered yet. And where there were gaps, he could predict all sorts of things about that element. He could predict about what its mass should be, depending on the group it was in, what type of properties it should have. And as a result of that, I'm sure several elements were discovered more rapidly than they would have otherwise. Our modern periodic table it just tweaked a little bit, tweaked Mendeleev's table, and this guy's name was Moseley. And instead of ordering the elements by mass, as Mendeleev did, he ordered the elements by their atomic number. Hopefully you remember that atomic number is the number of protons. Mendeleev's periodic table had a couple of anomalies in it. Some elements that fell into groups where they didn't really share properties. And so when Moseley came along and arranged it in order of atomic number, those anomalies went away. Really, if you compare Mendeleev's table to Moseley's, there aren't a lot of differences. Maybe 4 or 5 elements got switched in their order. So it wasn't a major change, but it solved some questions that people had about Mendeleev's table. So the major divisions of the periodic table that I want you to be familiar with is I first want you to be aware of and be able to reproduce the stair step on the periodic table. We call it the stair step because it divides the metals from the nonmetals from the metalloids. What am I talking about? The metals lie to the left of the stair step. So here's the stair step. The metals are everything to the left of that stair step. So obviously there are a lot more metals, there are a lot more metals than nonmetals. The nonmetals lie to the right of the stair step, and the metalloids, there are 7 of them, are elements that touch the stair step. Okay, not aluminum, even though it's touching it. That's an exception, and not polonium. But most of the others that touch the stair step are called metalloids. So just to briefly summarize the properties of these different types of elements, metals, as you probably know, are very good conductors of heat and electricity. They are what we call malleable. That means they can be shaped into different shapes. This is a weird one. They are ductile, which means they can be drawn into wires, and they're usually shiny. From a chemical standpoint, we have learned earlier that metals tend to lose electrons to become cations when they chemically react. Nonmetals have pretty much different properties, opposite properties from metals. Whereas metals are always solid, nonmetals can be any phase of matter. They are poor conductors of heat and electricity. They are not ductile, they are not malleable, and chemically they tend to gain electrons to become anions. The metalloids, there are 7 of them, which you should memorize. Okay, boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. As you might expect, the metalloids have properties in between metals and nonmetals. These mixed properties end up being very valuable in some industry. You're probably aware of the usefulness of silicon. Silicon Valley, they use them for microchips in the computers. Actually, I think they have better stuff now, but and the reason they're so valuable is you think about the motherboard for a computer. If you've ever looked at one, incredible detail, very, very small scale. And if they used metal for their circuits and things that are conductive there, the metals are too conductive and it probably blow things out. Silicon, which is a semi-metal or a metalloid, is only partially conductive, so it allows for the flow of electrons without going overboard and blasting everything around it. Now for some terminology. If you look at a periodic table, there are actually 2 numbering systems that are common. The older one is the AB system, 1A, 2A, and I want you to ignore these transition metals for now. And then it picks up 3A, 4A, all the way to 8A. So all the A groups are the main group elements, and the ones in the middle that are labeled B are transition elements. They're very odd, transition elements are, so we won't spend a lot of time on them. The more modern way to label the groups are simply 1 through 18, but you should be familiar with both methods. A vertical column is called a group, and a horizontal row is called a period. One thing that's really important to remember throughout chemistry is that elements in the same group, that is the same vertical column, have similar properties. Elements in the same group have similar properties. Okay, and that was the whole idea in development of the periodic table. That was how the periodic table got the shape that it has, is when we realized that certain elements have similar properties. I'm going to mention 3 or 4 of the more important groups that chemists work with very frequently. Group 1 or Group 1A, depending on what numbering system, are called the alkali metals. That's a name you should remember. They're actually the most reactive group in the periodic table. They are metals because they're to the left of the stair step. Extremely reactive. So you could take any of these metals and throw them in water and you would get an explosion. Alkaline earth metals are group 2A. They're a little bit less reactive than group 1A. And I don't know why the names have to be so close together. You've got to be a little careful. So group 1A is alkali metals, and the main difference is group 2A, alkaline earth metals. Skip over to the halogens. It's group 7A, and they're nonmetals. That's to the right of the stair step, and they're very reactive, and they, not surprisingly, tend to react with the metals in group 1A, which you will learn. And finally, the last group that I'm going to make note of that I want you to be aware of are the noble gases. They're on the far right, group 8A. The noble gases are what we call, for the most part, inert, which means non-reactive. And that's why they're called noble. That is it for the brief lecture on the arrangement of the periodic table.